Good morning, everyone. Today we are talking about this guy here, Johannes Brönsted, the man with the funny line through the O. Hi everyone. This video is about the acid and base concept of Johannes Brönsted and Martin Lowry. These two dudes here, we're going to take a look at what they discovered about acids and bases. Maybe you already know about the acid and base concept of Arrhenius. That is about how acids break down into H+ ions and acid radicals in water, and bases break down into OH- and base radicals. Okay, but the Arrhenius concept does have its weaknesses. One of them is this reaction equation here. Ammonium gas reacts with gaseous hydrochloric acid to form solid ammonium chloride. Here, the ammonia gas reacts as a base and the HCl as an acid. According to Arrhenius, though, this would not be an acid-base reaction. First of all, we have two gases here, so there is no water involved. Also, the base NH3 does not have any OH-, but NH3 still reacts as a base. So Brönsted expanded this theory. The new theory from Brönsted also works for gaseous acids and bases, and it explains why substances like NH3 can react as a base, even without an OH-. Okay. And how did Brönsted, this clever egghead, describe acids and bases to include gases and bases with no OH-? According to Johannes Brönsted, acids are so-called proton donors. An acid, which is a proton donor, donates at least one proton. Easy to remember, a donor donates. This means it gives a gift, or a donation. Here we have HCl and water. This becomes H3O+ and Cl-. The acid HCl donates its H+ to the water. This is what produces H3O+. HCl is the proton donor. Okay, good. And how do bases work according to Brönsted? A base in this theory is a proton acceptor. Bases are the ones who receive the gift. To accept means to receive. This is the same as an acceptor. So a base can receive an H+ ion, so it gets one more. Here is another example. This is the base ammonia. Ammonia has one free electron pair. This means it can receive one H+. When ammonia reacts with water, for example, it receives the H+ from water. The base essentially accepts the gift from the water. This produces ammonium NH4+ and OH-. Okay, good. All clear. Now, just one more little fact to understand it all a bit better. Here in the equation, the HCl gives up the proton, and the water receives it. So the water is the proton acceptor, or the base. The other way around, the water donates the proton in a base reaction. It gives it up. Therefore, water is the acid here. So crazy! By the way, HCl and Cl- are called a conjugate acid-base pair. HCl reacts as an acid in water, and Cl- reacts as a base. In this case, H2O and H3O+ are also an acid-base pair. This is explained in a bit more detail in the video on acids and bases. You can also recognize acids and bases pretty much whenever you drop them in water. Acids, like our hydrochloric acid, always form an oxonium ion with water, or H3O+. The remainder is the acid radical. Bases form a hydroxide ion with water, OH- and a base radical. The base radical is thus the base plus H+. Okay, good. But when HCl, for example, is not dissolved in water, it is an acid according to Brönsted. The water is just used to differentiate between acids and bases. The acid does not really need the water in order to react as an acid. It can also react as an acid in a gaseous state. This is the difference from the Arrhenius concept. Okay, what is important for you about the Brönsted theory is just that you remember the principle of a gift. The acid gives the gift of a proton, so it is the proton donor. The base receives the gift of a proton, so it is the proton acceptor. You can recognize Brönsted acids and bases when you put them in water. Okay, that's it for Brönsted. Bye!